Okay, this time we're going to talk about estimating solutions, and we're going to use the graphing calculator to help us estimate solutions here. So the real roots found so far have all been integers. Easy to find because they on the graph they just cross right at a point. However, the roots of quadratic equations are usually not integers. In these cases, we can use estimation to approximate the roots of the equation. So let's solve x squared plus 6x plus 6 by graphing. If integral roots cannot be found, when they use the word integral, it's the same thing as meaning integer. If integer roots cannot be found, estimate the roots to the nearest tenth. So if I graph x squared plus 6x plus 6, I would get the vertex, plot the y-intercept, and get the point on the other side, and you get the graph here. Now you could see that it does cross the x-axis at two spots. However, I don't know what they are because they don't cross right at a point. They cross somewhere in between. So this looks like it's somewhere between -1 and -2, and this one's somewhere between -4 and -5. So the x-intercepts are located between -5 and -4, and -2 and -1. So what we can do is make a table of values with an increment of 1/10 for the x values located between -5 and -4, -2, and -1. So here's the tables. And what we do, here's the one that goes from -5 to -4. And notice we just went up -4.9, -4.8, -4.7, -4.6, -4.5, -4.4, and so forth and so on, because we're looking to see where the sign changes, because you could tell that the y values here are positive, then it passes through 0 and it's going to go to negative. Well, it changes, the y values change from positive to negative right here. Well, you just picked the one that's closer to 0. Well, -0.11 is closer to 0, so the x value that corresponds with that is -4.7. Okay? Similarly, we're going to plot all the points between -2 and -1 and go up by tenths. So you had -2, then -1.9, -1.8, all the way up to -1.1. And then in the y values, you look for where it changes from negative to positive or positive to negative, which is right here. So I know the real answer is between -1.3 and -1.2. Since I'm estimating, I pick the one that's y value is a little bit closer to 0, which is this one. So from the table, the function value that is closest to the 0 when the sign changes is -0.11. So the roots are approximately -4.7 and -1.3. Okay, now let me show you how you can use your graphing calculator to figure this out. So if you go to the y equals menu and there's stuff in there, just clear it all out. What you do is you graph the function. Just put it in y equals 1. You would have x squared plus 6x plus 6. And then you want to hit zoom 6 to get a standard viewing window. And you could see the graph right there. Okay? Now, if I zoom in a little bit, so hit zoom 2, I'm going to zoom in right in the middle of it, right here, because I want to pull it closer to me. Okay, you could see it crosses between -4 and 5 and -1 and 2. Here's what you do. You hit second window, which is the table set. You want to make sure your independent is on ask. All you do is highlight ask like this and hit enter. Make sure your dependent's on auto. Highlight auto and hit enter. This table start and triangle table, don't worry about that. Those can be anything. Then you hit second graph, which gives you a table of values. And then you can plug in the numbers you want. So -4.9, -4.9, -4.8, -4.7, -4.6. And you see already, I don't have to keep going because I already had my y value change sign. It went from a negative value to a positive value, a positive value to a negative value, all right? And I know that negative 0.11 is closer to 0 than 0.24, so negative 4.7 is my approximate root. Then if I look back at the graph, remember it was between negative 1 and negative 2, so I can go back to the table, scroll up to the top, and go negative 1.1, negative 1.2, negative 1.3, and you're going to get the same numbers, negative 1.4, negative 1.5. But I didn't even have to go that far because I already got the sign change right here. And negative 1.3 has the number that's closest to 0. Okay? All right. So here's one for you to try. Go ahead and pause the video. Okay, guys, we're back. And so let's check this one out. So what I'm going to do is I'm going to graph it. Clear that off. You have 2x squared plus 6x minus 3. Zoom 6, standard viewing window. I'm going to hit zoom 2 and then put the thingies right in the middle here. And you can see it crosses somewhere between 0 and 1 and negative 1, 2, 3. So between x equals negative 4 and negative 3 and x equals 0 and 1. So I go to my table of values. Now once you do the table setup, it'll stay like that. So you could just go straight to the table. And then I'm going to go negative 4, negative 3.9, negative 3.8, negative 3.7, negative 3.6, negative 3.5, negative 3.4. All right, I got a negative number. See, so the y values all were positive, and then once I got to negative 3.4, it changed sign. So I have 0.5 and negative 0.28. Negative 0.28 is closer to 0, so my x is approximately negative 3.4. And then you go from 0 to 1. So 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. Okay, you see from 0.4 to 0.5, it changed from negative to positive. And the one that's closer to 0, the negative 0.28, is the one that I'm going to use as my approximate solution. So x is approximately 0.4. Don't put the negative 0.28 as your root, because that's not the x value. You see how your x value is right here. Okay, so my approximate solutions are negative 3.4 and 0.4. All right, so approximating x-intercepts of graphs is also helpful when solving real-world problems. So let's check this one out. A goalie kicks a soccer ball with an upward velocity of 65 feet per second. Her foot meets the ball 1 foot off the ground. The quadratic function h equals negative 16t squared plus 65t plus 1 represents the height of the ball h in feet after t seconds. Approximately how long is the ball in the air? Well, you need to find the roots of the equation negative 16t squared plus 65t plus 1 equals 0. So we can graph that bad boy on the calculator. Here's a picture of it right here. And what these numbers down here mean is the x values go from negative 4 to positive 7, and they're scaled by 1. So each little dot represents 1. The y values, however, go from negative 10 to 70, and they're scaled by 10. So each dot represents 10, not 1 in that case. Okay, so the positive x-intercept is approximately 4. So right here. All right, the other y-x-intercept of the graph is over here, and that would be like right before she kicked the ball, when the ball was on the ground before she kicked it. Okay. So it hits the ground. You could even see it's kind of like the ball goes up and comes back down and hits the ground here, approximately 4 seconds later. All right, so if the goalie kicks the soccer ball with an upward velocity at 55 feet per second and his foot meets the ball 2 feet off the ground, approximately how long is the ball in the air? Remember, you're going to use the equation negative 16t squared plus vt plus h naught. Go ahead and pause the video. All right, we're back. So this equation, the height is equal to negative 16t squared plus the initial velocity times t, which is 55, times t, plus the initial height, which is 2. Bust out your handy-dandy calculator. All right. Now, they said approximately how long is the ball in the air? Well, they didn't tell us to round to any or approximate to any specific accuracy. So let's just graph it and see what happens. So negative 16, let me do this, negative 16. Now you have to use x instead of t. X squared plus 55x plus 2. Now watch this. If I do zoom 6, probably not going to see too much. Well, not too bad. You could kind of see that the graph went up here and then came back down. That's because it's kind of, it goes up really fast and comes back really down. So if I change the scaling, I could see more of it. Like if I went to the window and went my Y-max, excuse me, yeah, my Y-max, made it go up to say 50 and then graphed it, you could see more of it. You see how it comes up, then back down. Okay, so what I want to do is zoom in to over here, because you can see that's where the graph crosses the x-axis there. And it crosses it between 3 and 4. See, 3 and 4. So I can go to my table and go 3, 3.1, 3.2. See, it's all positive. 3.3, 3.4, 3.5, 3.6. And you see it changed from positive to negative when I went from 3.4 to 3.5. The one that's closer to 0 is at 3.5. So t is about 3.5 seconds. Okay, so the ball hits the ground about 3.5 seconds later after he hits it. All right, well, that's it, guys. Thanks for your time and attention, and we'll see you later. Don't forget to move on to your assignment. Take care.